You see, this is our program. And our next participant will show us a music instrument that landed on the Smithsonian with force. And he is Brad Rodriguez. Are you ready, Brad, for the demonstration?
I don't have much in the way of demonstration, but I am ready for the presentation. Yes, I'm ready.
Excellent. Go ahead, please.
One thing I want to do is see if I can post in the chat a bunch of links. We'll see what happens. Oh, yes. They lit right up there. And they all seem to be there. Okay. Some time ago, well, actually a few times, Peter asked me to, what else have I done with Fourth? I'm mostly talking about Fourth internals. So I decided to talk about the surprise I got about 2 months ago. Harvey Starr, who is my longest standing client, sent an email basically saying, did I know that my work was in the Smithsonian? And of course, I had no inkling. And that's not exactly how he phrased it. He asked, did I know that one of these guitar instruments, musical instrument, was in the Smithsonian because he invented it and I've been doing a lot of programming for it. It's been a project of mine for a long time. So I said no, I had no suspicion, thanks. I'll bet I know just the group that would like to hear about this. And that's you guys. And it's also been in the London Museum of Science. So you guys in the UK can go over there and see it. I don't know if it's a visible display or if it's in storage. And the National Guitar Museum in the United States also has one. So that's the present. And I would like to go into the backstory now, how we came to this place at this time. For those of you who have not used it, MIDI, the musical instrument digital interface, was adopted first version of it was adopted in 1983, with the idea being that the controller of a music synthesizer, the keyboard or whatever else you're using to control it, should be separate from the synthesizer itself. Up until that time, they always been sold as a unit. You'd buy the keyboard and the synthesizer at the same time. And a lot of musicians were saying, well, I like let's say the Yamaha keyboard and the Roland synthesizer. Why can't I use them together? So this was a project of some of the manufacturers actually to make compatibility possible between their various pieces of equipment. And that turned out to be a really good idea. It gave lots of life to the music synthesizer industry and also opens some new applications. Now, in 1986, excuse me, Harvey Starr, who's the founder of Star Labs, that's one of the links.
Did we just lose Brad?
Yeah, he's frozen here.
He needs a better laptop.
I think it's his network connection.
Yeah, it's probably his uplink.
Yeah.
Well, we are waiting for Brad to come back. And we hope he's back. If not, meeting will continue with Richard. But I will give Brad a couple of minutes more. Well, there is no. Oh, he's back. Brad is coming back.
Can you hear me now?
Yes, perfect.
When did I drop out? It just froze here on me.
You just mentioned the Star Labs website and then bang, that was it.
Okay. I'll go to that. Fortunately, I have an outline here or notes I'm following. Star Labs, who is Harvey Starr, who owns Star Labs, who is in the business of creating accessories for guitars, decided he wanted to create a guitar formatted controller, not the synthesizer, but the controller. One of the things that happened as a result of the MIDI interfaces, synthesizers became hugely popular for working musicians, I shall say. One of the biggest uses for synthesizers was in commercial video, commercial film. You can imagine a movie will have a lot of orchestral music, perhaps, but there is a huge amount of demand for musicians that can play synthesizer and short musical pieces for advertising. You look at any television commercial, there's probably some music in it somewhere, and those are being eaten up by all of the keyboard artists. The guitar artists and others felt shut out. So Harvey decided that he wanted to make a controller that the guitar owners could use to control a MIDI synthesizer. And he did. That was the Zetar. He's in the United States, so it's Z and not Z. And that was about, well, according to Wikipedia, which is the only place I found the date for that, 1986. Well, up until the mid 1990s, he was having fairly good results with that. But his code was getting harder to maintain. So he did, I guess, a web search for Super 8 and 4th. Let's use the Zilog Super 8 processor. Super 8 and 4th, and found my name and contacted me, and I said, certainly I could do something like that. He was, at the time, using a 4th that had been provided by Zilog, which was what we call a resident 4th, like the MSP 430 Camel 4th, or any number of new Micros products. And to get the performance he required, he was using a lot of machine language primitives, and he was compiling them by hand using an external cross compiler, and then copying the hex codes manually into the file for his instrument. And you can understand that's an awful lot of work. And am I frozen again? No, I'm seeing motion. Okay, good. So he contacted me, and I basically recommended to him what he needs to use is a proper 4th cross compiler. And one was commercially available for the Super 8, and that was from Microprocessor Engineering in the UK, Stephen Peltz's outfit. So I recommended that, and he provided his code. I got all the code converted over to Super 8 or 4th source code, and he was happy. It was a lot faster to produce variants on the instrument now. He wanted to produce a lot of variants. Originally, pardon me, I have to reach for something out of my reach. Originally, he had a very large circuit board with a processor on it. This is not the part with the processor, but this gives you the idea of the size. This is the sensor pads that were under the first Zetar. And he had a processor card that was just about the same form factor that mounted on the back. Should hold that up longer and try to get it in the camera. There we go. That connector went to the processor card. And he wanted to prove that. So I designed, that was known as the D4 processor card. I don't know why his numbering system works the way it does, but that was the D4. So I undertook to produce the D5, which I did. It had 4 times the memory and was a smaller footprint. It actually would fit into a fairly small box. Hang on a moment. I'm going to keep this in my lap for a few minutes. How much of this can be seen? Okay, on the top, that's the D5 processor. And below it, down here, that's the D6 processor. And no, I got those backwards. I should have looked at this before holding it up. The top one is the D6, and the bottom one is the D5. The D5 give him 4 times the memory. Four times the memory and fit into a smaller space. It was a pin paddle with the D5 card, so that with the D4 card, so he could just pull one processor off and substitute the other. And that was great while it lasted. And you know how these things go. Zilog discontinued the Super 8 processor, which he was using in all of his instruments. So that came back onto my plate, and I put together the D6 processor with a different CPU. And spent a lot of time examining CPUs because I had a lot of assembly language to be translated and converted. And I wanted to find something that was architecturally fairly close to the Super 8 processor. And the closest thing I found was the what was then Hitachi and is now Renesas H8 family, the H8S in particular, to be specific. Pardon me for just a moment. And so I designed the D6 board and started working on converting the software. And the way I did that, because it was a large pain, rather than try to translate all the Super 8 source code to H8 source code, I built a cross assembler. It was an H8 output from a Super 8 input. Rather, you use Super 8 instructions while writing the code, Super 8 mnemonics and addresses and name contents and everything. And this would look at Super 8 source code and produce the equivalent H8 code for the output. So that made the D6 possible, pardon me, and also made larger programs possible. This thing kept growing and growing. During this time, some specialized instruments came to be used. For example, the microtonal keyboard. If you know a really esoteric musician, they might know about microtonal scales. It's not anything that isn't one of the 12-note octaves that we all know for piano or you name the conventional musical instrument. That's just a fraction. The microtonal keyboard allowed a field of 810 notes, and they're not spaced equally apart. I mean, they're spaced equally apart, but not 12 to an octave. It's probably more like 120 to the octave. That is for the most advanced music researchers. And the thing is, there's not a lot of those available. Not a lot of those made, and Harvey was able to do it. The D6 card. He also did a drum-based controller, instrument controller, and that was the event station. So instead of having a guitar as your control surface, as your controller, you had a drum set with electronic drum heads. They're actually piezoelectric heads that would generate pulses and send them into the processor. And that was reasonably popular, but it's been discontinued. Harvey loves doing, he's a brilliant guy, and he loves doing unusual instruments. He did a harp, just one. It was a special order, but he did a harp with sensors that he then fed into another D6 processor and generated MIDI code. So that takes us up to about 2004. That's where I have the note of the Super 8 being discontinued. In 2009, based on the good results with the D6 processor, he wanted to develop a next board, which logically is the D7 processor, using an H8S 2212 processor chip, because that chip supported USB, and he wanted to have a USB output. And it got developed, There's let me hold it up there. There's the D7 prototype. And there's the D6 it's replacing. Much smaller. Difficult to use, difficult to program, and he had found a conversion chip, I think one of the FTI chips that converts USB to serial and vice versa, and thought that was a much simpler solution. It added a bit to the cost of the board, but it was a lot simpler, and you didn't have to write USB drivers. So the D7 got shelved in favor of the simpler but more expensive approach. And that's about where he is technologically now. He's been still making D6s with a USB chip. He keeps doing instrument variants. Let me show you a couple. Again, the phones come off. Now, how to get this on camera? There we go. This is the Z6S, sorry, instrument with an experimental fingerboard here. It uses actually ribbon controllers instead of individual keys. Can you see what I'm? Yeah, you can see what I'm gesturing there at the top. But you can tell it's an experimental prototype by the spaghetti in the back. So this instrument with the ribbon controllers did not get made. It was another, experimental, theoretical, hypothetical instrument. And once it was built, it really wasn't entirely satisfying for the user. But he has been doing wonderful things like, okay, this will be a little tricky. This is a baby Z. How are we doing? Okay, you can see that. I actually have it connected here. And that's where the small form factor processor really helped out. Because that's, as you can see, well, it's going to be hard to hold them up side by side, isn't it? That's all I can do to hold one of them. How does that look? Okay, you can see the big versus the small. He has several other instruments that he's brought out. They're more toward a keyboard than a guitar. He has a 24 by 24 key matrix. That's the Z board 24. And he has smaller as well, 12 by 24 and 6 by 24, but they play as a keyboard. They don't have any strings. So this brings us to the present day. I get work from Harvey every now and then when he needs to make yet another custom instrument. Most of his work is custom work, and talking the regular instruments as well. If you go to the Star Labs website, you will see a gallery, and there's a whole lot of interesting, strange-looking instruments there. He's going out in the direction of distributed processing. All these that I've shown you are single processors, and he's going with the ARM architecture. So he's developing code for ARM in C. So since I'm not an ARM specialist nor a C specialist, he doesn't really need my skills for that anymore. I'm relegated now strictly to a support role and not a development role. But I've been getting 25 years out of this, so I've had a really good time with it. It's probably my most interesting. Well, it's certainly in the candidate for my most interesting project that I've worked on. That's the backstory. So finally, as far as I can tell, the Smithsonian has one of these because the user donated it. The guy who bought it from Star Labs used it for a little while, and then donated it to the Smithsonian. So that is the third of those links. But I see that my time is about up, so I'll ask if there's any questions.
Excellent talk, Brad. Fantastic.
Oh, thank you. Okay.
I think
There's a question.
there are Atli has a question. There are many questions on the chat, I think.
Yeah, no, I'm a Norwegian. The only thing I know about music is how to blast heavy metal. So forgive me for asking a stupid question. But it seems to me that on a guitar, you already have a sound generator in the microphone. Why not take that signal and just feed that into the synthesizer? It's something I've probably misunderstood something, but that is my question.
Oh, that's actually a good question, and there's an interesting answer behind that. But first, what you're doing with the controller, you're playing the controller as a musical instrument. It is outputting not music, but a MIDI stream, not audio, I should say, but a MIDI stream. And that MIDI stream is then fed to the synthesizer of your choice, depending on what effects you want or need. Hang on a moment. I have somewhere around here the synthesizer. How did I lose that? I'll find it in a few moments. Originally, when people started thinking about how can they get a guitar to control a MIDI synthesizer, they did close to what you were suggesting. They would say, all right, we have this audio stream. Let's look at it with digital signal processing, see if we can parse out the notes that are in that audio stream. And I understand that is now, that we're talking about the current day, being done with some success, but with the quality of digital signal processing available in 1983, they were horrible. They could not separate the audio. Like if you strum 6 strings, you have 6 notes all being output. Separating those out is a lot of work, and several were made. I don't think any of them were commercially successful. Harvey took the idea of, well, this what we want is a MIDI stream. Let's try to get that directly, not go through the audio stage on the way there. Did that answer the question?
Excellent, thank you. That I suspected it, but yeah.
Other questions?
So do you play, Brad?
I guess I'm back over to you then, Peter. Whoop. That's one of the jokes of all this. I have never played a guitar in my life. When I was in high school, I learned to play the clarinet. So I fiddle with this thing. I experiment with it, but I can't play it. I have it mostly spread out on my workbench. Don't play guitar.
Very cool stuff.
Sorry?
So very, very cool stuff. Very cool.
Oh, very cool. I thought you were saying radical, and I didn't know what was radical about this. Okay. Anyone else?
Well, fantastic presentation, Brad. And we love when you are in the meeting and show us your news. Fantastic.
Thank you.
Now we